Learning by Design, Good Video Games as Learning Machines by James Paul G. Summarized and presented by Melanie Gillespie. James Paul G. is a researcher, educator, and lover of video games. One day he asked himself, why are learners motivated to learn long, complicated video games, but not motivated to learn traditional subjects? So he did what any good researcher would do. He played video games. A lot of video games. Finally, he identified the principles that make video games such successful engines for learning. These principles are organized into three categories: creating empowered learners, well-designed problem solving, and encouraging understanding. The first two principles of empowered learning are co-design and customization. This means learners are interactive participants in the game. Their decisions affect outcomes, and they're encouraged to play the game in a variety of ways. Empowered learning also occurs through identity. There are two ways to get learners to invest in identity. First, you can create full identities that are so intriguing learners want to be invested. Second, you can create essentially empty identities that learners can design to their own specifications. The last principle of empowered learning is a bit complicated. Empowered learners engage in manipulation and integrate distributed knowledge. What that means is that video game action occurs through learner manipulation of characters and objects, which are essentially tools the learner uses to achieve their goals. Distributed knowledge means knowledge divided between multiple parties that requires the learner to integrate them. For example, a character knows how to perform the actions of walking and running, while the learner knows when to use one or the other. The learner must integrate her knowledge with the character's knowledge to successfully apply these actions in the game. The next category of learning principles is problem solving. The first two principles are well-ordered problems and cycles of expertise. These principles both relate to the design of the problem space. Well-ordered problems are arranged so that the learner understands all components before tackling complex problems. For example, you could learn to play a song on the guitar with no lessons about strings, chords, or reading music, but you wouldn't be able to apply that knowledge to play other songs. Cycles of expertise are designed to make learned skills automatic before introducing new skills. After learning various chords, you might practice them until you can play them without looking at the strings before you attempt playing a song. The next principle is pleasantly frustrating problems. Problems should be difficult enough to be challenging, but not so hard the learner gives up before solving them. Effective problem solving also requires information that is on demand and just in time. Good video games dispense new knowledge so it can be applied soon after it is received. By providing it in small bits only as it is needed, learners can process huge amounts of knowledge without being overwhelmed or dismissing it as irrelevant. Effective problem solving also benefits from metaphorical fish tanks and sandboxes. These principles both focus on controlling the learning environment. In video games, they are often available as training modules or introductory levels of play. A fish tank demonstrates variables and relationships removed from their complex real-world environments. For example, learners might study birds at a zoo to learn about anatomy and behavior before going on a bird-watching hike in the woods. A sandbox allows learners to explore new concepts or skills without the risks of real-world environments. For example, learners might practice with a driving simulation before getting behind the wheel of a real car. The last principle of problem solving requires using skills as strategies. Repetitive, out-of-context practice bores learners. Video games allow learners to use skills practice as strategy toward accomplishing goals. For example, to practice the skill of running, your character must escape enemies by outrunning them. The final category involves understanding. Video games enhance understanding by developing system thinking. In other words, learners put all knowledge in the context of the video game world. Rather than learning isolated facts they are unable to apply, they develop an intuition about the way things work in that world. Video games also enhance understanding by using meaning as action image. In other words, the meanings of ideas and identities are based on the learner's experience with them in the game. Even philosophical ideas are realized through image and action. What do these principles mean for education? Educators must embrace curricula that empowers learning by making them active, invested participants. Problem spaces must be well-designed with well-ordered, pleasantly frustrating problems that build cycles of expertise and provide information on demand and just in time. Students must be allowed to use skills as strategies and access controlled learning environments such as fish tanks and sandboxes. System thinking and meaning as action image must be the foundations for learner understanding. Learners can benefit greatly if teachers transform into skillful designers.
Created using Powtoon.